And welcome back to the Turdberg Show. This is part two in the series that we are doing on differential equations, kind of like in how they're used in physics. Some pretty basic stuff. So let's go ahead and take a look at this problem because we can kind of do a little bit of that in here. So an object has an acceleration given by ax of t is equal to dt squared. And then it tells us that when time is 0, that your x is equal to a, and when time is 0, your velocity is equal to b. And then it goes on to tell us that a, b, and d are constants. So for this object, what is x of t? So it starts us off with this equation for acceleration. I'm going to simplify and just write a is equal to dt square. And so we've kind of talked about this stuff before, how we can try and start getting this idea of that we can use some type of differential in here. Well, let's just go ahead and always be thinking about this goal of this problem is to get to x. Well, we've got acceleration. So what is acceleration for position? Well, easy. Acceleration is the second derivative of position. So we can use that as a way to get back to position. So I've got just a little idea, and we don't necessarily have to call this a differential equation video, but it gives us this idea of what it is that we're going to do. And let's go ahead and do some. Write down what the definition for acceleration is. Well, acceleration is what? A change in velocity with respect to time. So let's look at this now. So let's go ahead and multiply both sides by dt. And we've got dv is equal to capital D, which is a constant, t squared dt. Now, compared to like the last video we did, what's so great about this is this problem is ready to go ahead and take a derivative or to integrate. Now, you may be looking at this saying, but Mr. Cole, the goal is to get to xt. Shouldn't you have written this? And somebody could say this, shouldn't you have written this like this? And the answer is, well, yes, I could have. I could have defined acceleration as a second derivative, but I wanted to try and teach it in as easy as a way possible. And this is actually a little easier way to me of thinking about it. And I just want to teach in this video. I'll do another one where we take a look at it and the latter. But anyway, let's go ahead and do our integration here. And so we can integrate both sides because unlike the other video, this time we've got t squared dt, so we're ready to go. And remember, d is a constant, so it would technically be pulled out in front anyway. Let's go ahead and write down what we're integrating from here. And it told us at time of 0, x is 0 and v is 0. So that means we're integrating essentially from 0 to v and from 0 to t. And that is completely wrong because it told us at time of 0, what was the catch? At time of 0, velocity is b. So there, I almost made a blunder, but we saved it. Okay, so now we know exactly what we're doing. So let's go ahead and start our integration in this one. So this one's going to be easy. So we'll integrate dv first, and so that's just v, and we're going to evaluate that from constant b to v. And then what are we going to have on the other side here? On the other side, we've got what? D. Now let's do it. This one's real easy. Add. So that would be t cubed. Now divide by 3. And we're going to evaluate that from 0 to t. So let's kind of work this out and see what we've got. Well, let's evaluate the left side here. So we've got what? V minus b, and that sums up that side, equals, then on the other side, I'll write it out, d, and for t, we'll actually just use t over 3, whoop, not minus, but plus not plus, but minus d 0. And I know a lot of people will be like, but Mr. Cole, we could tell that this was going to be 0. Oh, could we? I just like doing it to make all the math teachers out there happy. But anyway, so there we've got this. So we know that velocity is equal to what? dt cubed over 3. Add b to both sides. So bam. So there is our equation for velocity. There's just one catch. This problem did not ask you to find an equation for velocity. It actually asked you to write an equation in terms of x. Well, that's fine. We're just working backwards. Remember what v is. V is a change in position with respect to time. T cubed over 3 plus b. I don't know why my little mouse is making a little pencil all over my screen. But anyway, let's multiply both sides by dt. So dx is equal to dt cubed over 3 plus b. And putting that up against what? dt. And so all you've got to do, and at this point, if you know how to integrate this, then you are fine. But it told us back at the beginning of the problem, it gave us some things here. It told us that when our time is 0, our x is equal to a. And so we'll go from a to x and from 0 to t. So let's go ahead and do a little work here. So take the integral of dx, so that's just x. And we're going to evaluate that from a to x. And again, if you know how to do the calculus on this, then quit watching this video. It's no longer for you. Now, if we're really being nitpicky on the other side, remember what we can actually do here. If you don't remember how to do this from, say, your math class, this other side really, it really breaks down like this, from 0 to t of dt cubed, and again, d is a constant, so we could pull it out, and 3 is a constant. We could pull that out. dt plus, we're also going to integrate from 0 to t, b dt. So there is actually what we're doing in terms of our math on this right side. So what do we end up with here? Well, let's take the integration of this. So dt cubed over 3, so add 1 and divide by it. So we end up with what? dt to the 4th, divide by that 4, so that gives us 12. Plus, on the other side, well, we got, what else have we got? We got b dt, so that just becomes bt, and we're going to evaluate that from 0 to t. And again, the only thing left now is just adding in, doing this evaluation. So our evaluation is x minus a on the left. Then on the right side, what do we got? We've got what? d t to the 4th, because we're actually using t for t, plus bt minus d 0 to the 4th over 12. Yes, I know it's 0. I just can't help myself. And then what else have we got? b times 0. So all this comes out to 0, but again, I just can't help myself. So we're ready. Just solve this equation for x now. So that means that x with respect to time is equal to dt to the 4 over 12 plus bt plus a. There you go, Mr. Equation. I hope you're happy with yourself. But anyway, this just gives you a little bit of an idea, and it's a fairly easy way to go at it. So anyway, nothing else to say other than toodles and have a good day. And how do you stop this video? Crazy thing.